They make money, people.
And they go to space?
Today, we will solve trigonometric equations. Ready, set, go. Our answers will be between 0 and 360 degrees. We are not going to solve in radians or in radian form. We will not do that. There's many adjustments, as Miss Maddie Mad Dog has been telling me about. You know, what are we choosing to keep? What are we choosing to skip in terms of our lessons? As you notice, we just skated right by 7.4. Sorry about that. I'm sure it greatly disturbs you. Yeah. Problem number 1, 2 sine of theta minus 1 is equal to negative 2. We want to know what angle would you plug in for theta. So does it say 2 sine of 50 degrees minus 1 is equal to negative 2? And what is that theta value? Anybody want to guess how I start? Add 1. 2 sine of theta is equal to negative 1. Divide by dos, which is Spanish for 2. We get sine of theta is equal to negative 1/2. That is not the answer, but it brings us to a way in which we find the answer rather easily. We're going to inverse sine both sides. But before we inverse sine both sides, we are first going to determine where is sine negative. Third and fourth, right. So I just want to go through the progression people went through. I heard people say all students take calculus. They're like, okay, so positive were the top two, so negative is the bottom two. My good friend Rachel Holcomb, you guys know Rachel? Here's how Rachel thinks through it, and this is how I thought through it. Is sine x or y? Y's. So y is positive up, it's negative down. See that? Cosine x or y? X. Cosine positive to the right, negative to the left. See that? So I'm going to be in the bottom two quadrants for sine, because sine is y, it's negative when it's down. I'm going to inverse 1/2 on my calculator. Do not include the negative when you inverse. You've already used up the negative by determining the quadrant. Turn my calculator on. I go, second, sine inverse, 0.5. I get 30. See it? So this is a 30-degree angle that's created here. We actually call it a reference angle. That leads us to the solution, because 30 is not in the third or fourth quadrant, isn't it? But a 30-degree angle in the third quadrant, what does that make that angle? 210 degrees. I took 30 and added it to 180. And then 360 minus 30 would give me 330 degrees. So notice if I take 2 times the sine of 210 degrees and I subtract 1 from it, I get, hey, there's negative 2. And if you typed in the same thing, but instead of 210, you put 330, you get negative 2 as well. It is cool. Number 2, what's different? Secant. No problem for us because we're geniuses. Is it geniuses or genii? Who knows? Add the 13 over, I get 11. Divide the negative 5. Secant of theta is equal to negative 11 over 5. Uh-oh. I don't have a secant button on my calculator. Samantha ate a bowl of Super Smart for lunch, and so she gets cosine of theta is equal to negative 5 over 11. She says if we know secant, we know cosine. We've got a cosine button on our calculator, no problem. Never scared her once. Where's cosine negative? Second and third. Remember, cosine is the x value. X is positive to the right, negative to the left. I'm not going to use the negative. I'm simply going to do cosine inverse of 5 over 11, and I get 62/96. 180 minus that. 117.04. And 180 plus that, and I get 242.96. Any questions on that? Oh, yeah, we can make them super complicated, but we're just going to make them somewhat complicated, okay? You try number 3 on your own. Go. Noah, you can do this. Yeah, let's try number 4. Let's distribute the negative 3 through. We get negative 6 cotangent of theta plus 3. Yes. Yeah. If we did 180 minus, that would bring us back into the second quadrant. So because it's in the third, we're going to do 180 plus. Remember, you want your final answer to be between 180 and 270. Those are those markers, right? Well, so your answers in this, so would you agree? Would you agree that your answer, because we're in the third quadrant, would you agree that your answer needs to be between 180 and 270? Because we are in the third, so you see how we're in the third quadrant, right? That's between 180 and 270, right? So if we did 180 plus 53, that would bring us into the third quadrant. If you did 180 minus 53, that would bring us out of the third quadrant. Yeah, so you add it. You want to be between 180 and 270. See if it works out for the next one, okay? See if it works out for the next one, okay? Negative 6 cotangent theta plus 3, and then plus 3 equals 6 minus 2 cotangent of theta minus 1. So you can see here I got a lot of pieces going on, but the fact is I just need to combine like terms, and they create one expression with cotangent. So I'm going to add the 3's together. Negative 6 cotangent of theta plus 6 equals 5 and, or 6 and negative 1 make 5 minus 2 cotangent of theta. Any thoughts on what we do now? Yeah, we're going to add 2 cotangent to both sides. And I'm also going to subtract 6 from both sides. And you can see here I have negative 4 cotangent of theta is equal to negative 1. Divide by negative 4, cotangent of theta is equal to 1/4. What now? Tangent of theta is equal to 4. So is the value of tangent positive or negative? It is positive. So therefore, which quadrants am I in? The first and the third quadrant. We go to our calculator. We have a button for tangent, so we tangent inverse 4, and we get 75.96. 75.96. We good? Okay. Now, Rach, again, your question. If I put a 0 here, a 90 here, a 180 here, and a 270 there, and a 360 here, as you head around in a counterclockwise fashion, as you move this way, you're going to add. As you move this way, you're going to subtract. So from 0, I add 75.96. From 180, I add 75.96. If I were moving, suppose it was in the second quadrant, suppose it was here, well, then I would have to move back from 180. And then that would be subtracting it. Yes, no? Okay. We'll have to try it together afterwards, okay? All right. So I'm going to take that 7596. And if I take the 180 plus the 75.96, I get 255.96. And there you have it, two solutions. So far, everything's come up as two solutions, right? Now, I suppose that what we have here is that you say, well, you know what? Everything's going to be two solutions. Not necessarily. You could come up with 0. You could come up with 2. You could come up with 6. You could come up with 3. And you just don't know until you actually work through the problem. What's different about number 5? It's a secant squared. And so that creates a little bit of a difficulty. We have 3 secant squared is equal to 11. We divide by 3. Secant squared of theta is equal to 11 over 3. Now we have two problems. You can either say, I'm going to get rid of the squared, or I'm going to change the secant. And I would rather change the secant right now. So I'm going to change it to cosine squared of theta is equal to what? 3 over 11. Now I'm going to get rid of the square root by taking the squared by taking the square root of both sides. And this is where we have a slight change. We end up with cosine of theta is equal to, do you remember what happens when you take the square root of a variable? When you got an x squared? What do you have to list? Both the positive and the negative. So what that means is that you look at your quadrants, we don't think about just where they're positive. We think about where they're also negative. So where is cosine positive? The right side, so the first and the fourth. Where is it negative? The second and the third. So we have how many solutions? We have 4 solutions. So I go to my calculator. Be careful as you type it in that you get the square root. We have cosine inverse of the root of 3 divided by 11. And I get 58.52. Notice as I'm writing the 58.52, I'm always placing it between the x-axis and the terminal side. Never the y-axis. Always the x-axis and the terminal side. Okay? So, Rach, we're getting right back to your question here. Maybe this one will work now that we have 4 solutions. It helps show the difference from what we had before. So if you notice, my first answer is going to be between 0 and 90. So I take 0 and I add on that 58.52, and you get 58.52. But if you look at this piece here, I'm going from 180. Here I have to subtract off the 58.52, and here I add on the 58.52. So because for this one, your answer has to be between 180 and 90, you subtract the 58. Because here your answer is between 180 and 270, you add the 58.5. So if we subtract the 58.52 from 180, we get 121.48. If we take the 58.52, we add it to the 180, we get 238.52. And then we have to, do we add or subtract the 58.52 from the 360? We subtract it. Yep. We subtract it off there. And we get 301.48 degrees. do 2 more problems. I'm going to let you guys work on a couple problems on your assignment. But, you know, this time we came up with 4 solutions. Number 6 is going to be even different. And if you notice, we have both a tangent squared and a tangent. Anybody want to guess what we do to solve this one? Take a tangent of theta out. Tangent of theta times 2 tangent of theta plus 1. So Logan sees that we got a factor. Factoring's our friend. Now we've got 2 different equations. Your first one is tangent of theta is equal to 0. Thank you for the excellent yawn. And then our other equation is 2 tangent of theta plus 1 is 0, or tangent of theta is equal to negative 1/2. Okay? So those are our 2 equations we set up. Which one do you want to deal with first? You want to deal with the one on the left side or the right side? It's up to you. Left side, tangent theta equals 0. That's tough for a lot of people to think about. If you inverse 0 on your calculator, you just get 0. So I want you guys to think of the unit circle, folks. I want you to think of the unit circle because we're going to get back to this in a little bit here. This point right here is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Do you guys remember what tangent is in terms of x and y? It's y over x. So if tangent is y over x, if tangent is y over x, which spots are going to give you 0? Where 0 is y. So this will give you 0, whereas this will give you undefined. This will give you 0, this will give you undefined, and this will give you. So if you notice, tangent's equal to 0 at 0, and then at 180, and then at 360. Yep. So that's our first set of solutions. Theta equals 0 degrees, 180 degrees, and 360 degrees. Now I got to solve tangent theta is equal to negative 1/2. Well, where's tangent negative? Second and fourth quadrant. It's okay. We thank you for answering. Second and fourth quadrants. Yep. I inverse tangent of 0.5, and I get 2657. So how do I come up with the first answer? 180 minus. And I get 153.43. And then take 360 minus 26.47. Or 57. And I get 333.43. So how many answers did we get there? You got 5. We're going to pause there. I'm going to let you work on a couple problems. Okay, what about problem number 7? There I got a cosine squared. I've got a cosine. I've got a 4. I got a 9. I got a 5. Any thoughts? Okay, and that's a common thought. Let's say you have 5x squared plus 9x plus 4 equals 0. Some people will do that. 5x squared plus 9x is equal to negative 4, and then factor out the x and get 5x plus 9. But the problem is that you're invoking a property that doesn't exist. We're invoking the negative 4 product property. What we want is the 0 product property. We have to have it remain equal to 0. You don't want to complete the square. We're just going to factor this bad boy. Yeah. 5 cosine of theta and cosine of theta. And doesn't that multiply to 5 cosine squared? Okay, then I need 9 cosine in the middle. I do 2 and 2, but that would give me 12. So I'm going to try 4 and 1. Does that give me 9 in the middle? Hey, look at that. Now I've got 2 equations I'm going to solve. We done factored that bad boy. Good job. So if I look to the expression on the right-hand side, I get cosine theta is equal to -1. Where is cosine equal to -1? Where on the unit circle do we have an x value of -1? 180 degrees. I have a second equation, 5 cosine of theta plus 4 is equal to 0. Or cosine of theta is equal to -4/5. Well, then we go back to our drawing, right? Where is cosine negative? Second and third. It's okay. We all make mistakes. The left side. Very good. Yeah. Very funny. Wow. Noah, what do we do about this? 3687. I feel better now that you guys are giving me a nice. Okay. So um so how do I get my first angle? Do I do 180 plus or 180 minus? 180 minus, I get theta is equal to 143.13. And then the second one I'm going to add, and I get 216.87 degrees. What do you think? Not too bad? Okay. Got a couple more problems to do. Flip it over. Okay, there we go. Please change that problem number 2 to 8 cosine of 4 theta plus 1 is equal to 5. Okay. What would you do in this situation? Yeah. Before we do that, just real quick, what makes this problem unique compared to the others? You have the 4 theta. This is what really makes it unique. And so this problem is new to us in how we handle that. First, we're going to subtract the 1. We get 8 cosine of 4 theta is equal to 4. Divide by 8, you have the cosine of 4 theta is equal to 1/2. Now, here's where some people start trying to divide the 4 off the theta, and you can't do that. Because order of operations say that if we were to plug something in for theta, say 3, would you take 4 times 3 first, or would you take the cosine of 3 first? Which one would you do? Yeah, you do 4 times 3, and then after that, you take the cosine. So we have to, when we solve, we do it in reverse order of operation. So we have to cosine inverse at this point. So when I cosine inverse, where is cosine positive? The right side, so quadrants 1 and 4. Anybody know what you get if you cosine inverse 1/2? I get 60 degrees. So you guys have been used to saying theta is 60 at this point, but we don't. You see the cosine is gone, but what's left? The 4 theta. So 4 theta is 60 degrees, and 4 theta is equal to, what's the other angle? 300 degrees. So if I want to solve this, what do you now think I do? Divide by 4, and I get theta is 15 degrees. Divide by 4, and you get theta is 75 degrees. So look at number 3. I've got a cosine and I've got a sine. Wouldn't it be nice if I could do something with sine and cosine to create one trig function instead of 2? Tangent, how? Divide by cosine. Ashley is a genius. We all knew that. It's okay. I'm sorry. I'm sorry I jumped to a different page here. Yep. So if I divide by cosine of x, what do I have on the left-hand side? Negative root of 3. What do I have on the right-hand side? Where's tangent negative? Not everywhere. They said that same thing last hour. Second of the fourth. Anybody know if you inverse the root of 3 for tangent, what you get? So x is 60, and x is 180. Oh, I'm sorry. I listened to Sam. I'm sorry. 60 is canceled. Now we got 1. Okay. Sorry, folks. All right, flip it over. We got to get through 5 and 6. I don't know if we'll make 6 today, but we'll for sure do 5. What makes 5 different? The last one had sine and cosine, and we got 2x. So what makes this problem really unique is that we have a double angle and a single angle. How do we work with both a double angle and a single angle? Wouldn't it be nice if, like, we had a formula sheet that told us how to convert double angles to single angles? Oh, we do have that? Double angle? Yeah, it says that the sine of 2x is the same as 2 sine of x cosine of x. Then I have minus cosine of x is equal to 0. YouTube, they wanted to cancel the cosines right now. No! No! Stop! Somebody else? Thank you, Sam. No, thank you, other Sam. Factoring out the cosine. And so I have 2 equations now, don't I? One of them is cosine of x is equal to 0. Do you remember from our work as we looked at the unit circle, since cosine's the x value, where is cosine equal to 0? 90 and 270. I knew that was coming back to you at some point. And then you have another set. You have 2 sine of x minus 1 is equal to 0, or sine of x is equal to 1/2. In which quadrants is sine positive? The top 2. I inverse 1/2 for sine, and what do I get? I get 30 degrees. And so we are left with 30 degrees and what? 150. So I apologize, folks. We won't be able to get to the last one. We'll have to quick pick that up tomorrow. But you won't be given anything new tomorrow. We'll just be ready to complete work on our study guide. There's a chance I'm going to be gone on Wednesday. Going to try to maybe pop over to Southwest and let some of those 7th graders know that they could sign up for track or golf or baseball or whatever spring sports are having 7th graders, tennis. So anybody that's allowing 7th graders, kind of let them know. So